Welcome to A Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 18 says, a student inflates a balloon. She uses a peg to keep the balloon closed. She then attaches a straw to the balloon using sticky tape. She passes a string through the straw and pulls the string tight as shown in the figure. The student removes the peg and air leaves the balloon. The velocity of the balloon increases from 0 to a maximum value. Explain how Newton's 3 laws of motion apply to the motion of the balloon during this time. So this question is very important one, and when you write down your answer, you have to write down your answer in a systematic way. Means the steps have to be written in an order, not in a random way. So it's very important, you need to organize your thoughts. So first of all, if you look at this balloon, it is given to us the student removes the peg and air leaves the balloon. So when student will remove this peg, air will go this way. So this is direction of air. Why air will go this way? Because there is force on air by balloon. So we can say because there is force on air by balloon. By Newton's third law, there will be a reaction force on the balloon as well. So this has to be in the opposite direction. So this will be force on balloon by air. So this is reaction force by air. So this is by Newton's third law. So we can say this is by Newton's third law. Now we need to understand, as this balloon will accelerate, because the speed of the balloon will increase from 0 to maximum value, balloon accelerates. So we can say balloon accelerates. So we can say balloon accelerates. As balloon accelerates because there is resultant force. There is resultant force on balloon. So we can say there is resultant force on balloon by Newton's second law. And this balloon will reach a maximum value. It is given to us, it reaches maximum value. When balloon reaches maximum value, V max, resultant force on balloon will be 0. Resultant force will be equal to 0 because in this case force on balloon by air will be equal to the resistive forces. So by Newton's first law, resultant force will be equal to 0 by Newton's first law. So this is how you can include 3 laws of motion to explain the motion of this balloon. So it's a systematic way. So first of all, we need to understand why balloon will move. When air is released from the balloon, there is force on the air by balloon. So by Newton's third law, there must be a reaction force on the balloon. So this is how you can include Newton's third law. Then we can go and we can think about why balloon accelerate. When something accelerates, there must be a resultant force. And acceleration and resultant force are explained by Newton's second law. And then finally this balloon will reach a maximum value. Now we need to understand, if the speed is constant, how about resultant force? Resultant force has to be equal to 0. And this is by Newton's first law, because when speed of the balloon increase, resistive forces also increase and they will balance the force on balloon by air. So its speed will be maximum. So these are the things we need to understand. Now let me show you the answer, how you can write down your answer in a systematic way. So this is how you can write down your answer. You can mention these points we have already discussed. So you have to write down 6 points. So if you have written first one, you will get 1 mark for this one, and then there is a second one. If you have written the second point, you will get another mark. The forward force on the balloon is greater than resistive forces, you will get another mark. By Newton's second law, the resultant force causes acceleration, so you will get fourth mark, means 1 mark here. As speed increases, forces change until resistive force equals forward force, you will get another mark, means you will get 5 marks. And the last mark is if you have written by Newton's first law, resultant force equals 0, so acceleration equals 0 at maximum speed, so you will get the last mark. So this is how 6 marks will be awarded to you. And this type of questions are very important and very helpful to improve your understanding of physics. So you can see how you can apply physics in a systematic way, and also this question helps you to understand how to look at practical applications of physics and how you explain any phenomenon in a beautiful way. Question 19 says the diagram shows a crane lifting a load. There is a large mass called a counterweight attached to the crane on the opposite side of the tower to the load. The crane has an electric motor with an efficiency of 47%. The crane lifts a load of 4.4 times 10 to 4 newtons. The load moves through a vertical distance of 15 meters in a time of 70 seconds. Determine the average power input to the electric motor. So for this question, first of all, you need to understand, imagine that this one is the electric motor. So we can say this one is the motor. So there is a power input, so we can say this is P in. So this is power input. This one has certain efficiency and we will get P out. So this is the power out. Efficiency we can simply write down. Efficiency, the percentage efficiency, this one has to be equal to useful P out. Useful P out divided by P in. So here we are talking about useful P out. So this is useful P out. P out has to be equal to P in, but P out will have useful power, so this will be P out useful, and also there will be P out wasted or dissipated power wasted. So this sum has to be equal to P in. So in this case we have P out. We can calculate P out is the useful work done by the crane, by the motor. We can calculate that one. So first of all we can say the P out useful, so P out useful we can calculate, that is equal to the work done by the motor to lift this load divided by time taken. So we can simply write down the work done by motor divided by time taken, so we can say delta T, and work done will be equal to force time distance, and force we have 4.4 times 10 to 4. This is equal to the weight of the load. So this is the force, and the distance we have, that is equal to 15 meters divided by time taken. Time taken in this case is 70 seconds. So we can calculate the value of P out. P out in this case will be equal to 9.4 times 10 to 3 watts. So this is value of P out. We need to calculate P in, so we can write on here P in, input power. This one has to be equal to P out useful. Very important ones, it's better to write down useful divided by the efficiency of this percentage efficiency. So this will be equal to 0.47. So this is 0.47. So we have P out, that is 9.4 times 10 to 3 divided by 0.47. So if we solve this one, in this case we will get 2.0 times 10 to 4 watts. So this is the P in. So one important point is you need to understand this has to be P out useful. Most of the time students they simply understand P out over P in, and that is not right physics. So you need to understand P useful. So this is how we can answer, and this question has 4 marks. If you have written these steps, you will get the 4 marks. The first mark will be given to you if you have used this formula. W, if you have written W is equal to this one, you will get 1 mark. So this will be the 1 mark. And the second mark you will get if you have used W over delta T, you will get another mark. And next mark you will get if you have written P out in this form, P in this form, you will get 1 mark. And the last mark you will get if you have got the right answer. So this is how 4 marks will be awarded to you. Part B says the horizontal distance from the load to the tower can be changed. The horizontal distance from the counterweight to the tower can also be changed. Explain how the counterweight needs to move when the load is moved away from the tower. Means if we move this load away from the tower, how we need to move this counterweight for this system to be in equilibrium. So first of all, we need to understand what is equilibrium, mean the conditions for equilibrium. For equilibrium, sum of the forces in any direction has to be equal to 0, and net moment about any point also has to be equal to 0. Net moment about any point has to be equal to 0. So it's very important to understand in any directions. So we can say resultant force in any direction has to be equal to 0, and net moment about any point has to be equal to 0. So this is very important, and this is complete physics, or we can say right physics. If you simply remember total sum of forces is equal to 0, that is not right way to state condition for equilibrium. Or if you only remember net moment is equal to 0, that is also not complete understanding of this concept. You need to understand net moment about any point has to be equal to 0. It simply means that sum of clockwise moments has to be equal to sum of counterclockwise moments. So this is one point we need to understand. So we can mark this one as 1 point. The second point we need to understand is when we move this load to the right, so clockwise moment, so this is the clockwise moment, this is our pivot, so the clockwise moment will increase, so CW increases. So we also need to increase the counterclockwise moment, so this one also has to increase. So how we can increase this one? We also need to move this one, this counterweight, to the left. So these are the points you need to understand to answer this question, and this question has 4 marks. So let me explain you how you can write down these 4 marks, and this is how you can write down these 4 marks. The first point, you can say total anti-clockwise moment is due to counterweight, means due to this counterweight. Total clockwise moment is due to sum of moment from beam and load, because this beam also has mass, so it has the center of mass. So from the center of mass, so let's center of mass somewhere, just approximate point, it has to be at the midpoint of this beam because this beam is uniform. So simply around here, I'm just marking here, so there is a weight of the beam, so this also will cause clockwise moment. So total clockwise moment is due to sum of moment from the beam and also from this load. Increasing the distance of the load increases the clockwise moment. So distance of counterweight needs to be increased to balance increase in clockwise moment, because net moment has to be 0 for this system to be in equilibrium. So this is how we can answer, and if you write down these points, you will get 4 marks. So here 1 mark for this one, and the second mark for this, and the third mark you will get for this point, and here you will get the fourth mark. This is how marks will be awarded. Second part says the beam is uniform with a weight of 3.0 times 10 to 4 newtons. The counterweight has a weight of 1.1 times 10 to 5 newtons. The load has a weight of 4.4 times 10 to 4 newtons. Deduce whether the load can be moved to the end of the beam without the crane toppling. The question is simply asking us, if we move this load to the end of this beam, this crane will topple or not. So this is what question is asking us. In order to answer this question, simply we need to understand for equilibrium, clockwise moment means the sum of clockwise moments has to be equal to sum of anti-clockwise moments. So we can simply say sum of clockwise moments has to be equal to sum of counterclockwise moments. So this is our main concept. We can also mark the midpoint of this beam. Midpoint will be around, here we have 1 2 3 4 5 6 7 8 9 10. It will be around here because we have 21 small squares, so it will be around here. So we can say this is weight of the beam is acting here. The length of this beam is 30 meters, so it means the midpoint is at 15 meters. This one is 8, so this distance, this has to be 7 meters. So we can say this is 7 meters. And for this load, we can just say for this system to be in equilibrium, let's say this length is equal to x, mean the distance from the center of the beam. Distance from the center of the beam, from here, from the center of this tower to the center of this load, let's say this distance is equal to x. So moment due to this one will be clockwise, moment is due to the weight of the beam also will be clockwise, and moment due to this counterweight, this will be counterclockwise. So we can say this will be counterclockwise. So first of all, we can look at clockwise moment due to the load. The weight of the load we have, that is 4.4 times 10 to 4 newtons multiplied by the distance from the center of the tower. Let's say that is x. Now we need to look at moment due to the weight of this beam. Weight of the beam we have, this is weight of the beam, so this is 3.0 times 10 to 4 newtons multiplied by the distance from the center of this tower. That distance is equal to 7.0 meters. Now we need to find moment due to this counterweight. The weight of this counterweight is 1.1 times 10 to 5, and its distance from the center of this tower is equal to 8.0. So from here we can find out value of x. If we figure out value of x, so this will be the maximum distance from the center of the tower. So x max in this case will be equal to 15.2 meters. So we have the maximum distance of the load, maximum possible distance from the center of the tower for this load has to be 15.2 meters for this system to stay in equilibrium. If we increase distance, this will just topple. So we can simply say this is the maximum distance without toppling. Without toppling. Now we need to find out the maximum distance we can move this load. Maximum distance means from here, and this maximum distance will be equal to, we have 8, so 30, this can be 22 meters. As in this case, as x max that is equal to 15.2 meters, that is less than 22 meters. So it means in this case this crane will topple if we move this load to the end of the beam. A practical question. If you look at the crane, when crane is working, and think about this principle of physics, you will see how crane works and how they adjust this counterweight. If they have to lift heavy weight or they have to lift lighter weight, so how they adjust this counterweight. Next time when you see crane in operation, look at crane carefully and try to understand the principle behind working of crane, means behind operation of crane. So you will see the real beauty of physics, means you will see physics in action. And this question has 5 marks. If you have written answer in this form, finally you have concluded, you will get 5 marks. Question 20 says an actor is wearing a harness. The harness is connected to a cable and support as shown in the figure. The force on the cable must not cause the material of the cable to reach its yield point. State what is meant by the yield point of a material. Yield point is a point at which there is a large increase in strain with small increase in stress. Or simply we can say yield point is a point at which there is a sudden increase in plastic deformation, or we can say is a large plastic deformation. That point we call is a yield point, and yield point is very important when we manufacture something or when we design something. So the safety factor is linked with yield point of a material. So let me show you how you can write down a proper answer. So this is how you can write down your proper answer. In the answer you can simply mention stress value at which material undergoes a sudden or large plastic deformation. That stress value is the yield point. You can see on this figure, this point is the yield point. Before this one, you can see the increase in strain and stress, they are proportional to each other, and after that there is a large increase in strain with small increase in stress, and material undergo plastic deformation. So this point we call is yield point. So this is how simply you can explain this question as only 1 mark. If you have written this one, you will get 1 mark. Part B says the cable and harness are used to accelerate the actor vertically off the ground. Explain why the forces acting on the actor cause him to accelerate upwards. So first of all, for this question, it is given to us actor accelerate upwards. So simply we can write down acceleration is vertically upwards. If acceleration is vertically upwards, so the resultant force also has to be vertically upwards. So simply we can say F net has to be vertically upwards. Now if you look at the forces acting on the actor along vertical direction, one force is the weight of the actor that is acting downwards, that is mg, and there must be another force on this one, that will be the pulling force, and the pulling force has to be greater than the weight. So simply we can say in this case actor is accelerating vertically upwards. It means there is resultant force acting on the actor along vertical. This question has 2 marks. So this is how we can write down our final answer. In the answer we can say the force from the cable on the actor is greater than the weight of the actor, so there is resultant force upwards. That's the reason this actor will accelerate upwards. So if we have written these 2 points, you will get 2 marks, one for first point and the second mark you will get for the second point. Second part says the actor has a mass of 77 kgs and is lifted vertically from the ground with an acceleration of 2.1 meters per second per second. Show that tension in the cable is about 920 newtons. As we already discussed that there are 2 forces acting on the actor along vertical. One is mg, that is acting vertically downwards, and one is the pulling force. We can say this is tension in the string, or we can say better way to say is the pulling force acting upwards. For this question we need to find out value of t, and acceleration in this case is vertically upwards. So simply we can start with F net is equal to ma, and F net has to be equal to t minus mg, and this will be equal to ma. We need to find out value of t, so simply we can say t is equal to mg plus ma, and we have value of mass, that is 77 kgs, and we have value of g, that is equal to 9.81. Again we have mass of the system, that is 77 kgs, and value of acceleration is 2.1. So we have value of a, that is 2.1. So simply we can plug in these values, and if we simplify, our final answer will be equal to 917 newtons. So this is value of t. So this is how we can approach this kind of problems. So the final answer for this question is 917. This question has 3 marks. 1 mark you will get if you have calculated value of weight. 1 mark you will get if you have used this formula. You will get 1 mark for this one, and the 3rd mark you will get if you have got the right answer. A beautiful way. So this formula is very important in mechanics. F net is equal to MA. Third part says to make sure the actor is safe, the stress in the cable must be less than 15% of the yield point stress. The cable has a yield point stress of 2.5 times 10 to 8 pascals. The diameter of the cable is given to us, and we need to deduce whether it is safe to lift the actor with an acceleration of 2.1 meters per second per second. We have already calculated the tension force, or we can say the upward force, that was equal to 917 newtons at A is equal to 2.1 meters per second per second. So we can find out first of all safe value of stress. So we can find out stress, safe value of stress. That has to be equal to 15% of yield point stress, 15% of this value. So we can multiply with 2.5 times 10 to 8 pascals, and if we multiply with this we will get 3.75 times 10 to 7 pascals. So this is the safe value of stress. Now we can find out the maximum value of stress. So stress maximum in the string, that one has to be equal to the force, pulling force, divided by the cross-sectional area of the string. Value of force we have, that is equal to 917 newtons, and value of A we can find out, that will be equal to pi by 4d square. So we can plug in values. 917 divided by pi by 4. Value of diameter of the cable is given to us, that is equal to 7.6 times 10 to minus 3 square. And if we solve this one, we will get 2.02 times 10 to 7 pascal. So this is the maximum stress. Now simply we need to conclude. So we can write down over conclusion. We can simply say as stress max, this value is less than this, so it's less than stress safe, means the safe value of stress. So it means that, so it is safe. So it means that this much stress is safe. So actor is safe if actor is accelerating with this acceleration, because the stress in the cable is lower than safe value of the stress. So it means that actor is safe. So this is how we can conclude. It's a practical question about designing, how designer works, how they make sure something is safe. And so this is how we can calculate, and if you have done this one, you will get 4 marks for this question. Total marks for this question are 4. Part C says the original cable is replaced with a new cable made from a different material. This material has a lower Young modulus than the material used to make the original cable. The new cable is the same length as the original cable but has greater diameter. The breaking stress is the same for both cables. Explain how the work done to break the new cable is different from the work done to break the original cable. Assume that both materials obey Hooke's law up to the breaking point. So for this question, it is given to us original cable. So we can simply write down here original cable, and we have new cable. So we can write down here first of all new cable. For these two cables, it is given to us they have the same length. So we can say they have the same length, and also they have the same breaking stress, same value of breaking stress. So these points we can write down. For new cable, it is given to us the diameter of new cable this is greater than diameter of old cable, or we can say original cable. But Young's modulus of new cable, this is lower than Young's modulus of old cable. In this case, we need to compare work done, and work done is equal to force time distance, but in this case it will be equal to force time extension. So we will write down delta x. So first of all, we need to find out force. To find force, we can use stress. The breaking stress, this is equal to the force divided by cross-sectional area. So we can say this will be equal to pi by 4d square. They have the same value of breaking stress, but in this case value of d is greater. So if d is greater, it means force has to be greater. So the force on the new cable, means F new, this one has to be greater than F old, or we can say F original, F old. So this value is greater, so we can update here, this value is greater. Now we need to find out a value of extension. To find extension, we can use Young's modulus. So this is Young's modulus, new value of Young's modulus. Young's modulus is equal to stress over strain. For this question, it is given to us this value of Young's modulus is lower. New value is lower as it is given here. Stress is the same, breaking stress is the same. So it means strain has to be greater. And strain is equal to extension delta x over x, or we can say delta L over L. You can also write down this is the extension divided by L original. They have the same length, but strain is greater, it means delta L is greater. We can also write down here this one is greater. We can also say delta L or delta X, it means extension. So extension is greater, force is greater, it means work done on new cable, this one is greater. So this is how you can answer this question. And these are the points you have to mention. So you can mention this point, same stress, area is greater, cross-sectional area is greater, it means the force on the new cable has to be greater. So we can mention these points in our answer. Then we can look at Young's modulus, as this value is lower, this value is the same, so strain has to be greater. As strain is greater but original length is the same, so it means delta L has to be greater, hence work done on new cable is greater. So this is a beautiful way, a systematic approach you need to develop in yourself, how to use a systematic approach to understand physics in a better way. I hope this one is clear to you. Now let me show you the final answer, how you can write down your final answer. I will clear this one and I will show you the final answer, how you can write down. In your final answer, we have to mention these points. We can say new cable has a greater cross-sectional area but same breaking stress, so greater force, because we have already discussed that stress is equal to F over A. A new cable has smaller value of Young's modulus, so there is greater strain for the same stress. So we can also say Young's modulus, this is equal to stress over strain. In a simple way you can write on here. So this value is lower, this value is the same, so this value has to be greater, this value is the same, this is greater, so this one has to be greater. So at breaking stress there will be greater extension because cables are the same length. So then we can also mention about the strain. So we have discussed these points. This is equal to delta L by L. If L is the same, strain is greater, it means delta L is greater. As force and extension both increase, so work done to break the new cable is greater than that for the original cable. So finally we can say work done, this is F times delta L. As delta L is greater for the new cable, F is also greater, so the work done is greater. So this is how we can answer in a beautiful way. I hope these questions make more sense to you and you have better understanding of these concepts. And that's all for today's lesson. If this video was helpful, please like and subscribe, and also you can join Patreon. If you need more help, you can also contact me directly for more help, and I'll see you in next video. If you have any questions, please leave your questions in comments and I will try to answer as soon as possible.